origin, to describe the position of the particle or a body at a point P, what I need a convenient point called origin, O. Average acceleration that is moved by object will be equal to this constant acceleration A. The velocity of one body with respect to the other, you are describing the velocity. That is known as relative velocity. Hello everyone, I am Nishma Nanjamma, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome back to everyone to my session 4 on chapter 4, Motion in a Plane. In this session 4, we will be studying what is velocity, average velocity, instantaneous velocity, acceleration, average acceleration, instantaneous acceleration, as well as relative velocity in terms of 2D plane. In motion in a straight line, in chapter 3, we studied velocity, acceleration and relative motion in terms of straight line, in terms of rectilinear motion, one dimension. In today's session, we learn all of these in 2D, that is motion in a plane. So before we start with, let's first try to understand position vector and displacement vector. Let us first try to understand position vector and displacement vector. Let us first try to understand position vector and displacement vector. In our previous session of chapter 4, motion in a plane, we have got a general idea about position vector and displacement vector. What is position vector and what is displacement vector? Then we studied resolution of vector in a session 3, resolution of vector. So using that resolution of vector, we shall study position vector and displacement vector. How position of object, position vector is divided or it is split into its respective components along x-axis and y-axis, and how displacement vector is resolved, is splitted into its respective components along x-axis and y-axis. So we will study in terms of resolution of vector, the position vector and displacement vector. So position vector, what is position vector? It specifies the position of the object in 2D plane. What does that mean? If I consider two axes, this is my x-axis and this is my y-axis. So I am trying to analyze the position of the object or particle which has moved from a origin to some point, say P, which has moved from origin to some point P in the plane. So what is plane? It requires two axes, x as well as y. So if this is my time along x-axis, position represented by x is along y-axis. So I require the two axes x as well as y to describe the position of the object in the plane. So this is my two dimension, that is plane, motion in a two dimension. So particle has moved from origin to some point P. So origin, to describe the position of the particle or a body at a point P, what I need a convenient point called origin, O. So I want to know from where to where did my particle or object move. So to describe the position of the object with respect to time, I need a convenient point called origin. So a particle has moved till point P. So the reflection, the projectile of particle P along y-axis is given by yj cap. The projection of P along y-axis is given by yj cap. The projection, the reflection of particle P or body P along x-axis is given by xi cap. So what is I cap and j cap here? It gives the direction. It is the unit vector represented by cap along x-axis and j gives the direction along y-axis. So I have a particle P. So the projectile of particle P in y-axis is given by yj cap, direction along y cap. So the projectile, the shadow that reflected in x-axis is given by xi cap. So a position vector, what is the position vector of OP? OP, position vector is given by R. Position vector is given by R. R is the position vector. R is the position vector of the line OP. This is the position vector. So how do you describe the position vector R now? R is given by xi cap plus yj cap. Xi cap plus yj cap. This is my equation 1. This is my equation 1. The position vector, the position of OP, line OP is represented by R. It is split into the position vector, that is the particle projectile along y-axis plus the particle's projection along x-axis. So I have resolved vector R. I have resolved vector R into its respective components, along x-axis and y-axis. The position of P, the position vector of P is resolved. How do you resolve? It is split into its respective component along x-axis plus its respective component along y-axis. So this equation 1 is your equation for finding the position vector. Equation 1 is for finding the position vector. Then what about displacement? What about displacement vector? How do you resolve the displacement vector to its respective components along x and y axis? That we will study here. For example, now I have a particle which has moved from origin to P. Now from P, it is displaced to some point P dash. I will join its line from origin. So I have a particle which has moved from origin to P, and from point P, the particle is displaced to P dash, displaced to P dash. It has moved from point P to P dash. That means it has changed its position. It is displaced. That means whether the displaced means it is nothing but displacement vector. The displacement of P dash, the displacement of P dash is given by delta R. What is delta here? What is delta? It is the change in position. How do you find change in position? How do you find displacement? It is the final position P dash minus the initial position P. That will give me the displacement vector. So the displacement P dash is given by delta R. Delta is nothing but change in position, difference. So from O to P dash, the position vector is defined as R dash. It is defined as R dash. R represents the position vector of line OP. R dash represents the position vector of OP dash. Displacement, it is displaced, the particle is displaced from P to P dash. That means P dash displacement is given by delta R. So what is your delta R then? Delta R is nothing but R dash minus R. Delta R, it is R dash minus R. Then you can look at the diagram here. If you observe the graph, it has undergone, the particle has undergone, if you see this, if you drop this line to x-axis, the particle has undergone delta x change in x-axis, and the particle has undergone, you can see here, delta y change in y-axis. What is delta x? That is nothing but x minus x dash. For P it is x, and for P along y it is y. For P dash along y it is y dash. For P dash along x it is nothing but x dash. So when you say, if you observe the graph, the particle P and P dash has undergone delta x change in x-axis and delta y change in y-axis. So you have R dash minus R, that will give me the displacement vector delta R. Delta final position minus the initial position. So we know what is r. It is xi cap plus yj cap. Equation 1. Using equation 1, I will solve this displacement equation to get the displacement equation. What is your delta r? It will be x dash I cap plus yj cap minus what is r? That is the position of p. It is not x dash, but it is xi cap plus yj cap. These are the respective components of vector r dash minus r along x and y axis. These are the respective components, the resolved components of vector r dash and r along x and y axis. So when it is r dash, you can see in x axis it will be r dash and in y axis it will be y dash. When it is p, the x axis it will be x and it will be y in y axis. Bringing the x terms together, I will get x dash minus x. I cap is taken common. Then again it will be plus y dash. This is y dash minus minus y. J cap is common in both. I have taken common. So what is your x dash minus x? Is nothing but delta x, and y dash final position minus the initial position in y axis will give you delta y. Substituting here, you will get delta r, displacement of p to p dash, that is delta r is equal to delta x I cap, direction along x axis, plus delta y, change in y axis, into unit vector, direction along y axis. This is my equation 2. This is my equation 2. So my equation 2 is the displacement equation. So my equation 1 is position equation. So keep in mind equation 1 and equation 2. How position vector is resolved, is splitted into its respective components along x and y axis. How the displacement vector from p to p dash, the particle is displaced. That is given by delta r. So delta r, displacement, change in position, is equal to change in particle's position along x-axis into I cap, unit vector along x-axis, plus change of the position of particle along y-axis into its unit vector along y-axis. So this is the equation for displacement. This is the equation of position vector, using how we resolve, using resolution. Keep these equations in your mind. It will be helpful for us to study velocity, acceleration in further slides. So next we have velocity. We have studied velocity in one dimension in the third chapter. Today we will study the same velocity. There is no much difference, but in the 2D plane, that we take both x and y axis to understand, to calculate velocity of a body or particle. So what is velocity? Velocity is defined as displacement per unit time. So change in position. When I tell change in position, whether displacement occur there? Yes. Change in position is what? It is displacement. So displacement by time. Change in position with respect to time. Change in position is what? Displacement. Displacement by time taken give you velocity. Velocity is equal to displacement by time. Give me velocity represented by V. So next, we got to know velocity is displacement by time. So what is average velocity then? What is average velocity? Velocity is a vector quantity, depends both on magnitude and direction. Average velocity represented by V bar. V, a line on its top. So V bar. Velocity of the particle is defined as the ratio of, it is nothing but delta R divided by delta T. So your average is equal to, average velocity is equal to delta R divided by delta T. So the ratio of displacement of particles, to the corresponding time interval. Ratio of displacement we have seen in the previous slide. It is delta R, displacement of particle from one position to another position. So the displacement divided by change in time, delta change in time. This gives me average velocity. And we know what is delta R there. So what is R vector? If you take delta out, what is R vector from the previous slide? Xi cap plus Yj cap is R. So Xi cap plus Yj cap. So this is divided by delta T. Divide each term by delta T and delta T. So it will be multiplied delta inside. So it will be delta Xi cap divided by delta T plus delta Y divided by delta T J cap. So this will give you your average velocity. So what is delta X? X, change in position by change in time. So change in position is what? Displacement. Displacement by time is what? Velocity. So average velocity, we can write VAV. Average velocity is equal to Vxi cap plus Vyj cap. So the change in the position of the object with respect to x-axis, the change in the position of the object with respect to y-axis. So change in position with respect to time is nothing but displacement. Displacement by time is nothing but velocity. So velocity along x-axis into unit vector plus velocity delta y by delta t is velocity along y-axis, change in position by time. So delta y into j cap. J cap is the unit vector along y-axis. So this is the equation for average velocity. Average velocity. Important. It is the equation for average velocity. Then what is instantaneous velocity? Instant. At that particular time. I have explained you in the chapter 3, motion in a straight line. What do you mean by instantaneous? Suppose a car is moving with some speed. At some time, he has to stop the car. Then again he'll move. Then again he will slow down the speed. So at that particular time, what is the velocity? In that instant of time, what is the velocity? That is the instantaneous velocity. What is instantaneous velocity? Velocity of the particle is defined as limiting the value of average velocity. Limiting the value of average velocity as time approaches to 0. We have to limit the value of average velocity as time delta t tends to 0. So it is change in R by change in t, can also be written as dr by dt. dr by dt. So we are limiting the average velocity delta r by delta t as time tends to 0. You can also write delta r by delta t as dr by dt. Now we got instantaneous velocity. I need to find out what is the magnitude. What is the magnitude? How will you find out magnitude? Magnitude V is equal to root of Vx square plus and Vy square. So this is the magnitude of velocity. Magnitude of the velocity. So we obtained this equation using this equation of average velocity. Using this equation of average velocity, by squaring and adding, I have got the magnitude of velocity. When squaring, I square unit vector square is nothing but 1. So we don't have I cap and j cap here. Unit vector, when it is square, it will give you the value 1. So this is the magnitude. Then how will you find the direction? So the direction is given by tan theta. In the previous sessions we have seen direction is given by tan theta. Tan theta is nothing but Vx by Vy, opposite by Vx by Vy, opposite by adjacent. Opposite, when you have an axis, x and y axis, opposite by adjacent. So if you want to calculate theta, when tan is taken to RHS side, it will be tan y by Vy by Vx. So this is the direction of object moving in a 2D plane. So tan is taken to RHS, it will be tan inverse Vx by Vy. You can see so many examples that a boy is moving towards east with some velocity, a girl is moving towards south with some velocity. To describe velocity, he is moving x as well as y axis. I need both. X from initial rest position is moving along x axis, and also I need to know what is his position. So I need both x and y axis to describe the motion when you talk in terms of plane. So at some point he will stop here. At this particular time, I want to know what is the velocity of this man who is traveling towards east. That is your instantaneous velocity. And limiting the value of average velocity as time tends to 0 is called instantaneous velocity. This is how you write instantaneous velocity, and this is how you calculate magnitude of velocity using the equation of average velocity. By squaring and adding, you get the magnitude, and you calculate direction using tan theta. Tan theta is Vy by Vx, opposite by adjacent. So this is the direction. So velocity is what? Change in position by time. That's nothing but displacement by time. So next you have, here you can see I have written expression for magnitude and direction of velocity in terms of its components along x and y axis. Along its components along x and y axis, I have written its magnitude. So the velocity of a boy moving towards east along x axis plus the boy who is moving towards east, the component along y axis. So this is how you calculate magnitude using the equation of average velocity, and this is the direction of V given in terms of tan theta. When tan is moved RHS, it will be tan inverse Vx by Vy by Vx. Next we have acceleration. What do you mean by acceleration? Accelerating, accelerate. So what is acceleration? We have studied in the previous chapter. It is change in velocity by time will give you acceleration. Acceleration represented by A. A is equal to velocity, change in velocity by time. Velocity or velocity per unit time is called acceleration. So what is acceleration? It is velocity by time. So here you can see this image. A boy is initially at rest. At this particular position, the velocity is, say it is V0 at time t0. As the time increases along the x-axis, so you can see this is y-axis, this is x-axis. As the time increases, the boy is increasing his speed. You can see this image, which is a good example to explain acceleration. As time increases along x-axis, he will move to the position V1 at time t1. So I want to know what is change in velocity. So that will give me acceleration. Change in velocity by time. How will you find change in velocity? So it is V1 minus V0 divided by T1 minus T0. If you find the change, we find the difference, you will get along x and y axis, you will get, substituting, you'll get what is acceleration. Similarly, like average velocity, I have average acceleration. What is average acceleration here? Average acceleration of a particle for a time interval delta t moving along a xy plane. It is a xy plane, x and y plane 2D. Is the ratio of change in velocity to the time interval. Acceleration is now what? Delta v by delta t. Velocity was delta r by delta t. So velocity is delta v by delta t. Acceleration is because velocity by time. So similar to the velocity, how will you arrive at this equation? So when I say delta, what is v there? What is v here? V is what? Vx I cap plus Vy j cap. So it will be Vx I cap plus Vy j cap divided by delta t. So split the terms into individual. So you'll get delta Vx by delta t I cap plus split the terms delta Vy divided by delta t j cap. So what is delta V? Change in velocity. Delta T, change in time. What is change in velocity by change in time? Along x-axis. So it will be nothing but acceleration along x-axis plus acceleration. So this is average acceleration bar, or you can also write AV. Average acceleration is equal to AX I cap. What is change in velocity? Delta V is change in velocity by change in time along y-axis. So it will be AY J cap. AY J cap. So this is my average acceleration. This is how I got this equation. So next I have instantaneous acceleration. A boy is initially at V0. He will increase his velocity. He will reach at point B. As time increases, say for 2 seconds. And again at 4 seconds, the boy has reached point C. He is increasing his velocity. So at this particular time, at 2 seconds, the boy is at position B. I want to know what is his velocity. What is his velocity? That is nothing but I want to know what is his acceleration at this particular time, 2 seconds. Where the boy is? He is at point B at time 2 seconds. So at this particular time, I want to know what is the acceleration of the boy. So that we call it as instantaneous acceleration. At that instant of time, what is the acceleration of the boy? It is instantaneous acceleration. Similar to velocity, it is nothing but the limiting the value of average velocity, delta V by delta T as time tends to 0. Instantaneous acceleration is the limiting value of average velocity as average acceleration as the time interval delta T approaches to 0. So what is instantaneous velocity? It is the limiting the value. We are using limiting the value of average velocity. Delta V by delta T is your average velocity, change in velocity by change in time. So limiting that value to as time tends to 0 is your instantaneous acceleration. How do you calculate the magnitude of acceleration A now? How did you calculate magnitude of velocity? Using this average velocity equation. Similarly, using this average velocity equation, that is AX, acceleration along x-axis, into I cap plus acceleration of a body along y-axis into j cap unit vector. So using this, squaring this, you'll get magnitude as magnitude A is equal to root of ax square plus ay square. In terms of velocity, we had vx square plus vy square. How do you find out direction? Similar to velocity, we have to find out the direction of acceleration here. It makes an angle theta. So with x-axis, that means it makes an angle theta with x-axis. I want to find out what is the direction. So I'll use tan theta is equal to tan theta. When you say acceleration, it is projectile on y-axis is ay and its projectile on x-axis is ax. Its shadow, its component, the vector A is resolved into its respective component with y and x-axis. So it is opposite by adjacent. That means ay by ax. You can also write tan theta is equal to, bring the tan to RHS, it is tan inverse ay by ax. So this is how you find direction of acceleration, magnitude of acceleration. Velocity and acceleration is easy to analyze, right? Velocity is given in terms of v, acceleration is nothing, it is given in terms of a with x and y axis along with the direction unit vector along x and y axis. So it is simpler. Next, we'll study motion in a plane. Motion in a plane with constant acceleration. What is this term? Constant acceleration. In a plane that is nothing but two dimension, that we use two axes x and y to represent the motion of the body. You can see a boy is standing at some height. So this is your y axis. So he is jumping into the water. This is your x axis. So this is we study the motion of the object, motion of the person, a body with respect to two axes, x and y axis. So this is what we call motion in a plane with constant acceleration. Acceleration is what? Change in velocity by time. Constant means it is same. The constant uniform acceleration. So what does that say? So you can see they are moving with constant acceleration, constant. So next, consider an object moving in xy plane. Consider an object moving in a xy plane with a constant acceleration. A particle, it is moving in a plane with a constant acceleration. Over certain time interval, you have time here, position here in the y-axis. Over a certain time interval, the average acceleration will be equal to this constant acceleration. Average acceleration that is moved by object will be equal to this constant acceleration A. Let V0 be the initial velocity at time t0 and V be the velocity at time instant t. So V0 is the velocity at t0, initial velocity at time t is equal to 0, and V be the velocity at time t. So initially the object was at rest, that was at position origin. So the velocity here, the initial velocity which it starts to move, be V0 and time be t0. As the object starts to move, the velocity will turn to V and the time will increase, so at time t. So A be the constant acceleration. Constant acceleration. Now, from definition of average acceleration, what is the definition says? That average acceleration A is equal to delta V by delta T. Average acceleration is equal to delta V by delta T. That means final position minus initial position change. Delta is what? Change in velocity. Initially the velocity was V0. Finally the velocity changed to V. So it is V minus V0 divided by what was the initial? Final time T minus at time T is equal to 0. This is time at starting V0. Time is equal to 0. So it is 0. So you'll get A is equal to V minus V0 by T. So this will be AT is equal to V minus V0. V is equal to, shifting the term, V0 plus AT. V0 plus AT. Now let Vx and Vy be the component along x and y axis. Now I got the velocity, equation of velocity. Now I have to resolve this velocity into its respective components along x and y axis. How will I resolve? So Vx be the velocity, Vy be the velocity of component along x and y axis. So this equation can be written as Vx is equal to V0x plus AT. This is along x axis. Then what about y-axis? It will be Vy is equal to V0y plus AT. This is along y-axis. These are the components of velocity along x and y-axis. So this is the component of velocity along x-axis and this is the component of velocity along y-axis. Now next, if I take let R and R0 be the position of particle at 0 and t. At 0, t is equal to 0 and t is equal to t. Let V and V0 be the velocity of particle, that is the object, at 0 and t. Now how do you calculate displacement? What is displacement? It is equal to average velocity. Velocity is what? Displacement by time. I want displacement. So displacement will be equal to average velocity into time. So when you have two objects, I'll do the measurement of velocity for two objects at certain time interval. When I want average, what I'll do? How do you find mean? It is the sum of two velocities divided by number of trials you have taken. R is my final position. R naught is my initial position. So V naught is my initial position, V naught, and V is my final position. So it is R naught and R, V naught and V. So that will be displacement is R minus R naught. Change, how will you find? R, the final position minus initial position is equal to average velocity. We have learned it is V naught plus V divided by 2. Finding the mean into time t. So how will you find out now? R minus R naught is equal to, what is V here? V is equal to V naught plus AT. Use equation 1 here. So what is V? V naught plus, what is V here? V naught plus AT. Substituting equation 1 in V. Here we get this equation divided by 2 into T. So on further simplification, V naught plus V naught, it is 2V naught plus AT divided by 2 into T. So 2 get cancels. Multiply the V inside, T inside. V naught T plus AT square. R minus R naught. I just want R. So 2 gets cancels. Half is remaining here. Half is remaining here. So I just want R. What it will be? It will be R naught plus V naught T plus half AT square. Half AT square. This is the equation for displacement. This is the equation for displacement. Now I want to resolve R in terms of X component and Y component. So how will I write? R is changed with X axis. It will be X is equal to X naught plus V naught XT plus half AX T square. And in terms of Y axis, the displacement is resolved into Y naught plus V naught Y plus half, this is T, plus half AY T square, AY T square. So I have to find out motion in a plane with constant acceleration. So this V naught is the initial velocity at time 0 and V is the final velocity at time t is equal to t. So A is the constant acceleration. My constant acceleration will become equal to average acceleration. So from definition of average acceleration, it is delta V by delta t. So final minus initial velocity, final time minus initial time. On simplification, I will get this equation V is equal to V naught plus AT. This is my first equation. So I have resolved this velocity into its respective components along x-axis and respective component along y-axis. I have resolved velocity. From this equation 1, remember this equation 1 because I need to substitute that V here. I next want to calculate displacement. So if R naught and R be the position of particle at 0 and t, V and V naught be the velocity of particle at 0 and t. So this is my initial displacement, this is my final displacement. This V naught is always initial velocity and this is my final velocity. Displacement is what? Velocity into time. Displacement, velocity is displacement by time. I want to calculate displacement, it is velocity into time. Velocity is what? I have two velocity, I want to find mean. So it is V naught plus V by 2. I have two velocity, V naught plus V by 2 into t. I have the value of velocity in equation 1. Substituting that, I'll get 2 V naught plus AT by 2. 2 get cancelled, half is remaining here, AT square multiplying t. I want to find out R naught goes to RHS. So this is the equation for displacement. I have resolved R in terms of X and Y axis. Next you have relative velocity. We have studied relative velocity in one dimension, in motion in a straight line. I want to find out relative velocity in a plane with two axes, X and Y, describing the motion of the car here, means describe the motion of plane here. I want two axes. In terms of 2D, I will describe the relative velocity. What is relative? It is the comparison between two objects. If a car is moving in a straight road, I have two cars. I want to know which car is moving faster. With the relative motion of another car, you can tell, right, which car is moving faster among the two. If I have single car, with relative to what? You will tell the car which car is moving faster. So, relative is the comparison. So, comparison, the velocity of one body with respect to the other. The velocity of one body. The velocity of one body with respect to the other. You are describing the velocity. That is known as relative velocity. Suppose we have studied relative velocity concept in detail in chapter 3. Please watch that session of chapter 3 where we have taken the illustration of a train, which will really give you a clear idea about relative velocity. So, how the object 1 is moving relative to object 2. How will I compare the velocity of one with another? Motion is relative. So, suppose if the two objects A and B, if this is the two object A and B, move with the velocity VA and VB. VA and VB. It's a vector quantity. Then the velocity of A relative to B with respect to B is given as VAB is equal to VA minus VB. Then the relative velocity of A with respect to B. Similarly, the velocity of B with respect to A is given as VBA is equal to VB minus VA. This VBA can also be written as, if I take minus sign, it is nothing but VB minus VA, vector VB minus VA. So, I can write VAB vector is equal to minus VB minus VA is what? VB minus VA is what? VBA vector. So, that is what I have written here. So, on taking modulus, next I will take modulus is equal to modulus of VBA vector. Modulus will give me positive value only. So, this is the relative velocity. How the object A is moving in relative to B, that is VAB, and how object B is moving relative to A, that is VBA. Finally, we get VAB is equal to VBA. So, this is about relative velocity. The velocity of one body with respect to the other is called relative velocity. Comparison between two objects. So, in today's session, we studied about the position and displacement vector in terms of resolution of vector. How do you split the position and displacement vector with respect to its component along x and y axis. With those equations, we studied what is velocity, average velocity, instantaneous velocity, and again we studied acceleration, average acceleration, instantaneous acceleration. For obtained equation for magnitude and direction for velocity as well as acceleration. Then we studied the motion in a plane, motion in 2D with constant acceleration. We arrived at the expression for displacement and velocity. So, next we studied the interesting topic, relative comparison, relative velocity in 2D, that is in plane. So, that's all for today's session, students. Next, I'll come up with a more interesting session in a motion in a plane, that is, we'll study projectile motion and uniform circular motion. Interesting, right? Until then, keep watching my sessions. Take care. Have a good day. Thank you.